So today we're going to look at linear equations and functions, slope-intercept form, and writing equations of lines. So this is a 2-day lesson. So for day 1, we're just going to do the first 2 pages of the notes. So as you can see, we're going to talk about what slope is. The biggest overall aha concept is right here. Slope is the constant rate of change between 2 quantities. So you definitely want to have that start. Super important as you go through your math courses, that if I ask you what is slope, your answer should be it's a constant rate of change. So you have learned in the past that the slope of m, which m denotes slope, of a non-vertical line, and the reason why it's non-vertical is, as you can see, my pointer right here is a vertical line. You cannot walk up a vertical line. It doesn't have a slope. Slopes are things that you can walk on. They are tilted in a particular direction every way, but not vertical. All right, so that's why it's a non-vertical line, is the ratio of the vertical change to the horizontal change. So your vertical change, if you recall, was called rise over your horizontal change, which is run. So here's your vertical change, this is your rise, and this is your run. So this is our rise, that's your change in your y values, and this is your run, your change in your x values. And so slope can also be noted as, this is a triangle y, but that triangle means change in y divided by the change in x. So you might want to note that that triangle right there means change. Okay, and then there's a formula you must know. So it's y sub 2 minus y sub 1. So that is your change in y. And so we get that from taking the difference between these 2 y values in 2 coordinate pairs. And it is divided by x sub 2 minus x sub 1. And again, we get that by finding the difference between these x values. So the difference between the x values is this horizontal change, and the difference between these y values is this vertical change. This is also called stair-stepping. You can stair-step above the line, or we could have stair-stepped our vertical change below the line and our horizontal change here. So you can stair-step above or below. All right, so let's look at some pictures of graphs. So as you look at a graph, I want you to determine or to think in your head, is the graph of that line a positive slope, a negative slope, a zero slope, or a no slope? And so you can learn line rises from left to right or line falls from left to right, but I don't particularly like that language. Instead, you can just look at the line, look at the tip of the line, right here or right here. That line is like a pointer, and it's pointing towards a particular quadrant. And so I want you to look at the tip of this line and determine, is it pointing towards a positive quadrant or a negative quadrant? And we only have to look at quadrant 1 and quadrant 2. So you do need to know the signs of your quadrant. So the sign of quadrant 1 is positive because it is bordered by positive numbers and positive numbers. And a positive times a positive is a positive. So that's how you can remember that the sign of this quadrant is positive. And then the sign of quadrant 2 right here is negative. Reason being, it's bordered by positive numbers and negative numbers. So a negative times a positive is a negative. So quadrant 2 is negative. As you can see, the tip of this line is pointing towards the positive quadrant. So this has a positive slope. Okay, then look at this second line. So now that you know what the signs of the quadrants are, this is positive and this is negative, you can see that this line is pointing towards the negative quadrant, quadrant 2. So it is a negatively sloped line, so it has a negative slope. Okay, then ask yourself here, first of all, you have to know that a horizontal line looks like the floor. Or oftentimes people will remember that this type of line is horizontal if you think about looking out at the horizon. The horizon goes in this direction. So you can think of a sun right here rising over the horizon. So the horizon is horizontal. So a horizontal line, I can actually physically walk on that. That's like walking on the floor. Since I can walk on it, it has a slope, and its slope is dun dun dun, suspenseful wait. The slope is 0, meaning it has no incline. And you get a 0 slope if your change in y is 0 over, you'll have some number here. So this is not a hashtag, it's a number. So you get a 0 slope because you have 0 over some number. That is going to equal 0. So anytime you have 0 in a fraction, you have to do something with it. You have to tell me what its value is, because if 0 is in the numerator, the value of that whole fraction is 0, because you're taking 0 and dividing it into, you know, an infinite number of groups. And if you divide 0 among however many groups, each group's always going to have 0. So that's why the answer is 0. If you look at a vertical line, remember a vertical line is the only line that you can't walk on. I mean, I guess you could walk on it if you were Spider-Man, but you're not. You may want to be, but you're not. So we can't walk on that line. So vertical lines have no slope, and we're not allowed to say no slope. So the slope here, because I don't know what you mean by no slope. I don't know if you mean the slope is 0 or undefined. So with a vertical line, you're going to say the slope is undefined. Oop. I just love my kindergarten handwriting. Imagine when you're typing on, or when you're writing on your computer, your handwriting looks terrible too. All right, so undefined. Okay, you can abbreviate that as UD, UD, and you get an undefined slope when you have a number in the numerator, but 0 is in the denominator. So that creates an undefined slope. Okay, so let's look at several examples, and we're going to calculate the slope for each of these examples. So for example 1a, you can do a couple things. So for all of these, I'm going to put up here that you, and if I were you, I'd write this as well. Just choose any 2 points. It doesn't matter whether you're looking at a graph or a table of values. Choose any 2 points that you want to. Okay, so choose any 2 points. Make sure that they are integer points. You're not choosing points that are fractions or decimals. And so let's look at this table of values. Normally, I would go ahead and choose any 2 points in this table of values, and I would use the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But I'm going to show you a different way in a table of values that's going to relate to the next page of your notes. So I want you to look, if this is a linear function, it will have a constant rate of change between all the x's and a constant rate of change between all the y's. For instance, the difference from 1 to -3 is a -2. Whoops, hang on. Let me move this out of the way because it's getting into my tools over here that you can't see. All right, so that's -2. And the difference from -3 to -5 is -2. And I'm writing a negative because we're moving in a negative direction from -1 to -3. We're becoming more negative. And the difference between -5 and -7 is also -2, so you can see that constant difference. -2 and -2. Then let's look at the difference, the constant difference between the y's. From 13 to 16 is a +3, and from 16 to 9 is a +3, 19, or 16 to 19. 19 to 22 is a positive 3. 22 to 25 is a positive 3, and 25 to 28 is a positive 3. So if we were to use that slope is the change in y over the change in x, our change in y is 3 divided by our change in x is negative 2. So we would say that this is negatively sloped function, and its constant rate of change is negative 3/2. Now this negative can either be in the denominator or the numerator, or it can just be hanging out to the side. It doesn't matter. You choose. All right, so now let's look at a graph. If I look at a graph, I'm going to choose any 2 points on that graph. So let's choose this point right here, which is 4, 5, and I'm going to choose this point right here, and I'm going to do this one 2 different ways as well, and this is 7, 2. Now normally when I have a graph, I'm not going to use the slope formula, but I want to demonstrate it for you, so that's why I'm doing it on this one. I'm going to show you the other method that I would use as well. So I'm going to label my points as point 1 and point 2, so it doesn't matter which is which. So this is going to be x sub 1, y sub 1, and this is x sub 2, y sub 2. And then I'm going to use the slope formula. So m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So what you want to do is write that formula every single time. If you don't know it, write it. You're more likely to remember it. Then we're going to write that formula as a template, is what I like to call it. I'm going to remove all the x's and y's, and I'm going to only put in, oh, and I guess I need my m because that's what I'm trying to find. And then I'm going to substitute in for all of my x's and y's. So my y sub 2 is 2. So I'm putting in a 2 here. And then my y sub 1 is 5. So I put a 5 here. And then my x sub 2 is 7. And my x sub 1 is 4. And then you either use a calculator or do the math. So 2 minus 5 is a negative 3. 7 minus 4 is a positive 3, which turns out to be negative 1. So the slope of this line is negative 1. And if you think about it, the tip of this line right here is pointing towards quadrant 2, which is a negative quadrant. So it makes sense that we would have a negatively sloped line of negative 1. The way that I prefer to find the slope on a graph is by stair-stepping. So I'm going to find the rise and the run. Now you can create a stair step above and go up and to the left, but since I've already written a lot of stuff up here, I'm going to stair step below. So I'm going to go down and to the right. You always want to go in your up-down direction first, and then your right-left direction. So our vertical rise is actually negative. So this is our vertical rise. Whoops, here. Let me erase that. Let me do that again. Maybe. Okay. Okay. Oops, I went too far. Went a little crazy there. Try it one more time. 3rd time's a charm. My stylus is not participating. Okay, so that rise was down. Since it's down, it's negative. And didn't I go down 3 spaces? So that's a negative 3. And then my horizontal run is going to be to the right, and to the right is a positive direction, and so that is going to be a positive 3. And so my slope, which is change in y, that's a y over change in x, those are triangles, is going to be a negative 3 over positive 3, which gives us a value of negative 1. And isn't that the same value that we came up with down here? So it doesn't matter which way you do it. You can stair step it or use your slope formula. All right, so then let's look at our next two lines. So your next two lines should ring a bell. As you look at this line, you should be making the connection that this line is a horizontal line. All horizontal lines have the same slope. So since it's a horizontal line, its slope, and I can walk on that line so it has a slope, its slope is 0, right? And then the next line is, this line right here is a vertical line. So the connection you should be making with a vertical line is that its slope is undefined. Okay? Undefined. So just to help you recall, how do we get a 0 slope and an undefined slope? So remember, with a 0 slope, your slope must have had 0 in the numerator and a number in the denominator. To get an undefined slope, your slope must have had a number in the numerator and a 0 in the denominator. You cannot have 0 in your denominator. All right, so let's look at page 2. So in page 2, we're going to actually look at the definition of a linear function. Linear meaning line, function meaning it passes the vertical line test, no x values repeat. So for something to be a linear function, it will be a function whose graph is a straight, non-vertical line. Oops, hang on. Let me get my pretty colors back. Okay, so it's a straight, non-vertical line. Then the next blank refers to the common difference. There is a common difference from each x value to the next and each y value to the next in a table. So we did that common difference when we did example 1b, or I'm sorry, example 1a. So please put an arrow towards C example 1a for the common difference. That's how we found the slope to that table of values. We found the constant change in x's, which was -2, I believe, and then the constant change in y's, which was 3, and so we got our slope that way. The function whose line is a straight non-vertical line, you can see those functions in examples 1b to 1c that we just looked at. All right, so then a function will have two variables, an x and a y. So the independent is your x, and the dependent is your y. And so you're looking at an equation, and the examples over here got all messed up when I typed this, and I didn't realize that, so I'll fix it here in a minute. But let's talk about, if you're looking at an equation, how do you determine if it's linear? Just looking at the equation, not looking at the graph. So it has two variables, an x and a y, and then there's three exceptions that you want to look for. It does not have exponents with the variables. I don't know how you want me to say that, but the variables won't have exponents. In other words, the exponents have to be 1, so x to the first, y to the first, for it to be a linear function. If you have x squared or x cubed or x to the 4th, it becomes a curve. So the exponents, no exponents with a variable. Then the next exception would be that there will be no variable under a radical. So I'm going to abbreviate that as rad. So remember that radicals can be written as fractional exponents. So they count as an exponent that's not 1. So anytime you have a variable underneath a radical like the square root of x or the cube root of y, that's going to make our function not linear. And then the last exception is that no variable, so that's var, no variable, in the denominator of a fraction. So in the denominator. And hopefully you know that the denominator is in the bottom of a fraction. So then let's look at our examples over here, and I'm going to have you put some lines to separate where they should be separated. So for our proper examples of a linear function, I want you to put a line between the 4 and the y, and then a line between the parentheses and the y, and a line between the x and the x over 3. And then let's move this over a little bit to the right, because I need you to add on to c equals, you need c equals 2 pi r. Okay, so these are perfect examples of a linear function, because notice that all the variables have an exponent of 1, and none of them are in the denominator of a fraction or under a radical. Y has an exponent of 1, so does x. No x or y is in the denominator of a fraction or under a radical, so that's linear. On this one, we have a fraction, but notice that the x is in the numerator. That's okay. And then your exponents are 1. And then here we have two different variables that are not x's and y. We have an r and a c, but they're both to the first power. And this does not count as a variable because pi is actually a number, 3.14 da 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 da, right? It's an irrational number. It just looks like a variable. Okay, so let's look at some non-examples. So we are going to put some more lines because these ones are messed up too, of course. So let's put a line between the 2 and the x squared, and a line between the 9 and the y, and a line between the radical x and the y. So these ones here are non-examples. They are not linear. They're actually curves. This one is not linear because the x is squared. So we have an issue with exponents. And then this one is not linear because both the x and the y have exponents other than 1. So again, we have an issue with exponents. This one, the y is okay, but notice that the x is underneath a radical. So remember, radicals give us exponents that are fractions, and they're definitely not 1. So because we have a variable underneath a radical, that's why it is not linear. And then finally we have x here in a fraction, but it's in the denominator, and we can't have that. So I'm going to put, whoops, that would be wrong. All right, I'm going to put denominator, or denom, since I'm running out of room, and hopefully you realize that that's the denominator. Okay, so let's go ahead and look at the bottom of this box. Move this up. So how do we find the solution to a linear equation? So a solution is going to look like any ordered pair. So ordered pair goes in there. Any ordered pair that makes the equation true. And of course your ordered pair is going to look like an x value with a y value. Linear equations, a linear equation has an infinite, whoops, having trouble spelling today, has an infinite, that's an N, oh, I'm trying to write small. My stylus is not working. That's infinite number of solutions. And a linear equation also has an infinite, I'm doing a much better job on this one, number of non-solutions. So what would be 3 solutions? Let's look at this graph over here. So 3 solutions. For it to be a solution, the ordered pair needs to be on the line itself. So for instance, this ordered pair right here is at 3, 6. So 3, 6 is an actual solution. And then this ordered pair right here is on the line, and that's at 5, 4. And then a third ordered pair might be here, and that would be 8, 1. So those are all solutions, but there's an infinite number of ordered pairs on this line because the line goes infinitely in two different directions. Now a non-solution would be any ordered pair that's not on the line. So for instance, this right here is a non-solution. So that would be the ordered pair of 2, 2. Non-solutions make the linear equation false, where solutions make it true. Another non-solution might be over here. So that would be 7, 8, right? So 7, 8. And then perhaps, I don't know, oh, we'll do this one right here. And then that would be 0, 7. Those are all non-solutions. They will not make the equation true. So let's identify, and this will be the end of today's lesson. We're going to identify which of the following points or ordered pairs make that linear equation true. So we're going to use y equals 6x minus 4 as our blueprint, if you will. And so I'm going to write it down each and every time. And everywhere that I see a variable, I'm going to put in parentheses. So I'm going to put parentheses for my y and parentheses for my x. So I'm going to write my rule this way, my linear equation this way. So 6 times parentheses and then minus 4. I guess I should have saved a little bit of room. I want to note that this 0 there is our x and that 0 there is our y. So I'm going to put a 0 in place of x and a 0 in place of y. And you're just going to work the left side separately from the right. So the left side has a value of 0, and then 6 times 0 is 0 minus 4. So 0 equals 0 minus 4 is negative 4. Is it true or false that 0 equals negative 4? Since 0 does not equal negative 4, this is false. It did not make the equation true, so therefore 0, 0 is not a solution to y equals 6x minus 4. So then what I want you to do is pause the video, and I want you to look and determine if these 3 ordered pairs are solutions to this equation. So you're going to do just what I did here and determine, does the left side equal the right side? So pause the video and run through the problems and then restart it and see how you did. Okay, so hopefully you pause the video, but I'm going to label each of these x and y, x and y, x and y. And then I have all of my templates that I'm getting ready to sub into. And then, so my x is 2, and my y is 1, my x is 1.5, and my y is 5. My x is negative 2, and my y is negative 16. Okay, so here's my work. I've got 1 equals 12 minus 4. 1 equals 8. Since that is not true, then no, it is not a solution. I'm not going to write out what I did on the left. I'll let you do that. And then on the third one, I have 5 is equal to 6 times 1.5 is 9 minus the 4. 5 is exactly equal to 5, so that is true. So then yes, 1.55 is a solution. And then finally we have negative 16 is equal to negative 12 minus 4. And that is negative 16 equals negative 16. So yes, negative 216 is a solution. And we're going to stop there for today. Let me know if you have any questions on your homework.